So welcome to the second lecture, and no big intro here. The geography of child penalties is the title of today's talk.
Thanks for showing up. I'm gonna pick up from some of the things we talked about yesterday for those of you who were there. I basically, after the three talks I'm going to give here, you're going to know about child penalties that you ever wanted to know, because I'm going to keep beating a dead horse about them. So yesterday, one of the things I spent quite a bit of time on was to sort of show you a bit about the geography, actually, and how we've been trying to estimate child penalties in many different places, but without even really talking too much about how we do that. And so today I'm going to sort of take a little bit of a step back and talk about how we're trying to map the geography of child penalties around the world. So just to recap from where we were yesterday, I talked about the fact that gender inequality is closely linked to parenthood or having children. Child penalties tend to be very large and very persistent in most places, so that in a number of countries, eliminating child penalties is virtually synonymous with eliminating gender inequality in labor market outcomes. At least until some of the things I talked about yesterday, that conclusion or this type of evidence really came from a very small set of countries, started with Denmark and a handful of other northern or central European countries with great admin data. And so that really raises the question of whether that's sort of a phenomenon unique to those types of countries, or if this is a finding that's more universal. And so in order to answer that question, we want to sort of say something about how things look like in a much wider set of countries. Also, I think the really key question in this literature has to do with mechanisms or underlying drivers. And to be able to answer that, it would be very helpful to have a lot more variation, a lot more countries, different types of settings. So that's kind of what I'm going to do today. Now, you don't have the kind of data we have in Denmark or Austria or other countries where we've done this in most countries in the world. So it requires a modified approach that sort of takes into account for the data that's available. So it's not going to be quite as perfect as some of the things we've done for other countries. So the idea here is to provide not perfect answers, but pretty good answers to some things we're interested in. And I'm going to sort of develop this approach in the context of the US, draw a US map, and then I'm going to build it out to the rest of the world. So a very brief history lesson just to remind us what people have been doing over time in the labor economics literature that has studied the impact of children of parenthood on different outcomes. So as usual, like yesterday, you can't really see the title of these slides, but it is what it is. So in a nutshell, so this is my very brief history lesson. People started out in the 60s and 70s and 80s, basically just running regressions of different outcomes on children and established a ton of correlations between children and different outcomes. And the obvious concern there was, of course, the endogeneity of fertility choices, which made it really hard to draw any very conclusive inferences from those correlations. Then people really started thinking seriously about the endogeneity and hunted for various instruments for childbirth. We talked a little bit about that yesterday, instruments such as sibling sex mix, IVF treatments, twinning instruments, et cetera, et cetera. And so that literature produced a number of really interesting results, but it does have a limitation, or two limitations, I would say. One is sort of external validity. Usually this literature, because of the nature of those instruments, tend to look at very particular types of treatment effects. the impact of the third child, the impact of having twins. So that's one part of the external validity concern. Another part of the external validity concern is that they typically look at small and selected samples. And so we do worry about whether some of those causal impacts really extend to the entire population and can be used to say something about the implications of this for aggregate gender inequality. The other limitation of these approaches is statistical power. Often we work with very small samples. So typically what that literature was aiming to do would be to provide a good estimate of that treatment effect. You know, we get a significant impact of having a third child. But in order to go beyond that and saying, well, why do we see this impact? What are the underlying mechanisms we drive that? We need more power to be able to cut the data in different ways and look at very granular sources of variation. And that's kind of what molded what I call the postmodern literature up here, and I just call it postmodern because it came after modern, which is what we do, which was simply to look at event studies of childbirth. So we just, as you saw yesterday, we use panel data on labor market outcomes for people who have children, and basically plot that around the event of childbirth. There were some details that got into that approach that I'll come back to later. But the neat thing about this approach is that that's something you can do for the entire population of parents. The treatment is happening for every single parent, so you have an enormous amount of statistical power when doing that, and you can cut the data in very granular ways and begin to think about mechanisms. And so that's sort of everything that came before what I'm going to talk about now, which is sort of today's lecture, which is, well, the limitation still here is we can only do this in places where we have large panel data sets. We've typically done it with admin data. And we would like to be able to extend this to countries where we don't have such data. So what I'm going to do today is to sort of talk a little bit about this pseudo event study approach based on repeated cross-sectional data, or actually not even necessarily repeated cross-section. You can do it with just one shot, just one wave of cross-sectional data. And the big advantage of it is that we have that kind of data available in so many different places. Okay, so let's talk a little bit about that method. By the way, we're taking questions along the way. That's up to you whether you want to ask questions along the way or do it at the end. Maybe
This was what do you prefer?
I'm open.
So please, if you have a good question.
Only if a good question. All right.
I think you can remove the bar by clicking more.
That's a very good comment.
It's not a question.
Floating.
Sorry, so what do I then share?
Floating.
Go down hide.
Hide, floating. This one?
I think so.
That was a huge contribution. Okay, so let me talk a little bit about the method first, and then provide some US evidence. Okay.
Yeah.
Okay, so now it works again. Okay, I see. All right. So what we're going to do is really very simple. We're going to basically try and use cross-sectional data combined with matching to create a pseudo panel around childbirth so that we can implement the kind of approach we've already done on the panel data. And once we have that, we're going to run event study specifications along the lines of what I showed you yesterday, based on Denmark and other countries. The good thing is that we have the panel data approach, which we believe works in part because we validated the panel data approach against other approaches where we use control groups or instruments. So we now have a panel data approach that we've done for a number of countries where it works. And now we can validate this, and then we can go one step further away and validate this cross-sectional approach against the panel data approach. So I'm going to implement this for the US first. So one of the great things about working with the US is that the US has great survey data. For this exercise here, I'm going to use CPS data, current population survey data, and American Community Survey data combined. These are great surveys. CPS data we have back to 1968 until present day, and ACS data we have from year 2000 until present day. And as you can see, these are really large data sets, right? The ACS data is about 22 million observations, and CPS data, 22 million households, and CPS data is more than 5 million households. We also have panel data in the US. And I guess the two very useful data sources there that I use are PSID data and NSLY data. But you can see those data sets are so much smaller, about 8,000 households in each. So what you can do, and what I will do, is to estimate the child penalty based on an event study approach for the US as a whole. I'm going to pool these two data sources, so I have about 16,000 households. So I can do that for the US as a whole, but you can't really do much more than that. As soon as you begin to cut that data, say look at different states, you just get a lot of noise. So we're going to validate an approach based on this data against this data for the US as a whole. And once we've convinced ourselves that it works at the level of the US as a whole, we're going to work with this data and start mapping out the geography and look at other sources of heterogeneity as well.
So why don't you do this with tax data and as a benchmark, like it uses good admin data?
Yeah, so that would be great. It says so we don't have access to the tax data. It's not that easy to get access to the admin tax data. But yeah, that would be even. So if you had the tax data for the US, then you have full population panel data for the US, and there would be no need to work with this data at all. So the reason why I think it's interesting to work with this data is that for for most countries, we don't have access to population-wide tax data at all. So we would like to use that, but I could of course validate it against that instead. So that would be a more powerful validation. And we would have certainly done that if we had the tax data. Yeah.
So in the study with Jacob Denmark, there you are basically using all the variation. There you could also, you only use a cross-sectional variation, I guess.
Absolutely. So that's one of the things, actually, it's on my to-do list to talk to Jacob about that, because we can validate. So this is brand new stuff that I've done in the last couple of months, and now I'm validating against this panel data for the US, but we have a bunch of other countries, Denmark, Austria, Switzerland, where we can validate and really see that. Yeah, I agree completely. Okay, so let me just sort of explain what is the fundamental concern here when we use cross-sectional data. Well, the fundamental concern is that there's a selection into being a parent, which is unsurprising. And the specific issue here is that parents are positively selected. So we can see that in this table here. Now, the neat thing is that we know from the child penalty event studies that we've seen that having a child is a non-event for men, and that holds pretty much universally. So we know that we have the answer for men. There really should be no difference between having a child and not having a child. For women, it's more tricky because there we also have the child penalty. So men reveal selection, and you can see here that that selection is positive. Employment rates are much higher among men and children. Earnings are much higher. Education is much higher. Fraction merit is much higher. Men and children are also older on average, et cetera, et cetera. And of course, you can just run a regression and try to control for some of these things, but we would always worry about whether we can deal with this by only controlling for selection on observables. Unobservables will always be a concern. So that's the fundamental issue here, and that's kind of why the basic regressions that people work on early on probably don't have a causal interpretation. So what are we going to do? Well, we're going to do the following. So let me just outline the approach here. So, so as usual, we're going to denote event time. We're going to index time relative to the birth of the first child. So that's event time. We're going to call that T. In cross-sectional data, we observe people who have children, and we also observe the age of their child. In other words, we know the event time for everyone with a kid. But those are only positive event times because they have kids. So we observe event times T greater than or equal to 0. Then we have a bunch of people without kids, and for them we don't observe event times. We know neither whether or not they will ever have kids, and if they do have kids, we don't know when. So we can't assign negative event times. Now, how do you then turn that into, we need to turn that into a panel where we have both positive and negative event times. And I've tried a number of different ways to do it. There are more or less sophisticated or complicated ways of doing it. The way I'm going to show you here is really very simple and I think works really well. So consider a specific parent observed in the data at event time 0. So they have a child of age 0 in a certain year, Y, and at a certain age, A, and with a certain set of demographic characteristics, XI. And simply what we're going to do is that we're going to exactly match one-to-one matching of that parent to some non-parent who is observed S years before, being S years younger, and having the exact same demographic characteristics, same gender, same gender, same education level, same marital status, et cetera, et cetera. And we're going to say that's the observation for event time minus S. Okay, so instead of trying to, often what we do when we are matching is where the ideal we have in mind is that we want to try and recreate a randomized experiment. So what I'm doing here is different because I really believe the panel data approach. So I'm instead creating a panel. So the matched person here has a different age and is observed in a different year, just like in a panel, but have the same demographic variables in terms of those things that are more or less time variant, certainly gender and race, of course, time variant, but also the other variables are much more slow moving. You can think of them as sort of more or less time invariant for people in this age group. So the advantage of this method is that in one go, like there are two aspects of this matching, that we need to, there are two things we need to achieve here when we match. One is that we need to figure out whether or not people will become parents ever. In condition of that, we need to assign them event time. And perhaps the most natural way to have done this would be to do that in 2 stages, which is much more clunky. The neat thing about this one is I do it all in one stage. This matching both selects the people who will become parents and gives them an event time. And in some sense, you say, once I've done that, you can sort of see how does that deal with selection. Let's go back to table we saw before. So the left part of this table here just replicates what you saw before, the observed differences between, I focus here on men because men are the ones that reveal selection, men with and without children, and we have these differences that we talked about before. And then here we have, it's the same history, so now I was there. We have the match men, and here specifically I'm comparing match men at event time 0, that is the year of birth of the first child, and event time -1, the year before childbirth. And then you can see that now they're closely matched on employment rates, fraction with a college degree, fraction married, and so on. But they're not perfectly matched because remember I've created a panel. So for example, earnings are still different. It's much less different here than it was over here, but it's not exactly matched. And it's not supposed to be because I've created a panel. Men at event time -1, they're 1 year younger and observed 1 calendar year before. So just because of time changes and life cycle changes, they're different. Similarly, there's an age difference of almost exactly 1 year. That's by construction because people assigned to event time -1 are in this approach 1 year younger.
Do you match them on income characteristics as well, or only on the other stuff?
So I match only in these things here. Yeah. And I'm going to sort of show you some graphs later that indicates that this is sufficient. Okay, so now we have our pseudo panel, and with that, then we can implement the usual event study approach that we've been doing, and other people have been doing a bunch of papers to estimate child penalties. So we're now just going to treat this as a panel, and with rest labor market outcomes on event time dummies. Controlling at the same time for life cycle trends through these age dummies and calendar time trends through these year dummies. This is the specification that underlie many of those graphs that I showed you yesterday. And then we're going to focus on the percentage impact of children on each gender. We're going to implement this separately for each gender, and we're going to focus on percentage effects here. So this is just the event time dummies divided by counterfactual outcome. And then what we call the child penalty is just the difference in the causal impact of children on men minus the causal impact of women. Okay, so I'm going to show you a bunch of graphs just like yesterday that plots these guys for men and these guys for women and see how they diverge before or after. Okay, so how does that look like? So on the left side here, you have that implemented. So here the outcome is earnings. This is the pseudo event study approach implemented with the cross section. And then we compare that over to here to the same approach implemented with panel data, PSID, and NSFY combined. And so as you can see, the two graphs look overall similar. So the child penalty measured with the cross-sectional approach is 31%. It's a little higher when measured with a panel data. But in some sense, you can say that this graph here is just a less noisy, a more precise version of the same graph over here. So
I was wondering, so you match on marital status and education.
Yeah.
Aren't those likely to be timed with co-timed with the arrival of children? And I was wondering whether you in some sense run the risk of rigging a flat pretrend because of that.
Well, maybe I don't think so. Let's. I think I have a graph here that would speak to that somewhat. I should say though that I focus here on people having their first child between age 25 and 45, and so education choices in the US are largely done at the age of 25. Right. So that's after most people would be done by college if they go to college. So, but let's maybe look at these graphs here, because, so what I'm doing here is that I start from a very parsimonious specification where I don't match on a lot, and then I gradually add things that I match on. So start up here in this corner here, only use year, age, and gender and nothing else. And you can see the positive selection on men here. You can kind of also see the positive selection on women, because of course there is a drop for women, but it just looks so small compared to what we normally see, right? So here you really have the positive selection, but you do have the parallel pre-trend is already there. Then you add education, and you can see what happens is that it reduces the jump up for men around childhood and increases the drop for women around childbirth. You add marital status, it goes even more in that direction, and then finally you add race and state, and then you're back to one where men are flat and women have this short drop here. And given everything we've done with real panel data across countries, really my goal here is, in some sense, I'm taking the stand that once I've made men flat, then I have my answer. Of course, I don't observe that ideal for women, because they have the child penalty. So the assumption here is that, not that the selection bias is the same for men and women, that can be different, but that, that whatever controls for selection for men also does that for women. So Selection bias is different for the two in the sense that, you know, if the selection bias were the same, this child dependency number would be the same across all specifications. You just move men down or women down around childbirth symmetrically. That's not what's happening. There is actually more selection for men here. The child dependency is much bigger. Yeah.
You also said that you're selecting on people becoming parents from age 25 to 40.
45, 20, for age of first birth,
Yeah,
focus on 25 to 45.
but I just Googled and like the average age of first-time mothers is 26 now. So you're throwing a lot of people out of the sample, right?
Yeah, so 26 sounds a bit low. I think it's more like, that sounds a bit too low to me. But the bottom line is that doesn't, so I've tried to do it unrestricted. I basically, you know, I tried pretty much all permutations on that. So that's actually not a very critical sample restriction. But 25 to 45 is what we have, you know, people have done in other papers as well. But yeah, I was trying to avoid the issue with having very young people giving births is not, so if someone has their first child at age 20 and I'm matching them, then to get 5 pre-birth years, I have to match people to back who are age 15, where labor market outcomes begin to become pretty meaningless. So the 25 was really chosen with that in mind, that now I'm matching for people who are never younger than 20 in terms of labor market outcomes. But actually, this really didn't make much of a difference.
So is it correct to understand that so your method is perfect if like parenthood is random conditional on the controls, and if there's a bit of a bump up that reveals that there's that reveals whatever selection is left once you have control.
So my method is perfect if the timing of first birth is random up to a trend, because I'm comparing men and women, so it's just a parallel trend assumption. You don't have to say, so the timing of first birth is random up to a trend, conditioned on having absorbed gender-specific age and calendar year effects. So, of course, in terms of the short-run penalty, what happens right around the birth of the first child, the identification assumptions, because they were really relying on smoothness. It's really the sharp drop here that identifies the effect. But as we go out here further and further away from the time of having the first child, we are really relying on this sort of this parallel trend assumption between men and women. And because we are conditioning on age and year, what's really changing here, so how do we get variation in event time, conditioning on calendar year and age? Well, as we go out here, if you are at a given age and in a given calendar year, if you are at one event time further out, you must have had your child 1 year before. So the age of first child is falling as we go. So this is a trend with respect to the age of first child. And we're assuming that that's the same men and women, conditioning on the controls. I think we're going to hear a paper later discussing this precise assumption. But that is what we're assuming. So this is for earnings. And the next graph here is for employment. And you can see the employment graphs do even better. They're essentially identical for the cross-sectional approach of the panel. And you just see the amount of precision you can see here. The confidence intervals are so tiny that this is something we can really work with in terms of looking at heterogeneity. Okay, we also, so one thing I'm going to distinguish between is, so these graphs here are for annual employment. We also have weekly employment, and weekly employment is even more precise. And again, here you can see kind of that the cross-section is a similar version to the panel data version, except that it looks better and is more precise. When I say look better, it has better pre-trends. Okay, so that's the basic approach. Now let's think about, how does that vary across space and across time? in the US. And so these were some of the graphs I showed you yesterday. Let me show you these graphs. So these are focused on earnings penalties first, and here I've selected 6 specific states in the US that kind of span sort of different parts of the country and sort of different types of economies, cultures, and so on. So you have a state like Maine up here, where the earnings penalty is relatively small, about, well, it's 26%. And then I've ordered them here by size of the penalty. So higher in California, higher in Illinois, in Georgia, New Jersey, and then Utah. As we discussed a little bit yesterday, Utah is always an outlier in the US in terms of child penalties. And it's of course also a very conservative state religiously. So that's earnings penalties. You can then do the same with employment penalties, and they're here. We have North Dakota, Washington, DC, Texas, California, New York, and Utah. And again, a ton of variation from 15% in North Dakota to 37% in Utah. You can look at other types of heterogeneity spatially. So I have some other spatial dimensions here. So the left one here compare red and blue states. So the red states are the Republican states, the blue states are the Democratic states. Here just specifically defined as having voted consistently Republican in the last 4 presidential elections or consistently Democratic in the last 4 presidential elections. This might be some way of getting maybe at culture or norms, but you can see when we define it this way, we actually don't see much in the US, right? The child penalties are very similar, and in fact, slightly larger in the Democratic states. But of course, being red and blue in the US is correlated with many other things. So the blue states will also tend to be more rural, have more agriculture, and a number of other ways that we think may matter for child penalties. And we can kind of see maybe one source of that over there on the right, where we compare metro and non-metro areas, and you can see that child penalties are different in those 2 areas. So basically, the child penalty is smaller in rural areas than it is in metro areas, and then may have to do with some of the things we discussed yesterday, having to do with the general equilibrium of the labor market, the types of jobs that are available in cities versus outside the cities. Another thing that I find quite useful to look at is this graph here. So here we just look across the US. So we're plotting on the left here the child penalty against the actual observed employment rate for mothers across US states. And what you can see in this graph here is kind of what we would expect, that in places where the employment rate is relatively high, the child penalty is also relatively low. Kind of what we would expect, because that suggests that, one of the reasons why we see variation in employment rates across different places in the US is because child penalties are different. And then essentially, you can sort of, if you add the child penalty back into the employment rate, then you can back out what is the counterfactual employment rate for mothers? That is what the employment rate would have been if not for the impact of children. And then this graph here, plotted against the employment rate, is much flatter, right? So if you look across US states, the variation in the actual employment rate is sort of 25 percentage points up almost, whereas the variation in the counterfactual employment rate, as without the child penalty, is not much more than 5 percentage points. In other words, most of the variation in employment rates comes from these child penalties. Okay, so that's some of the cross-sectional variation states. You can also look at how, well, so this is just a heat map that puts all of this together. So this is a heat map for the US. Darker colors means larger child penalties, lighter colors mean smaller child penalties. We have earnings and employment child penalties. And yeah, so what you can see here, looking for example at the employment penalties, you can see you kind of have generally small penalties in the central north part of the US and kind of larger child penalties in the west and the south and the east. It's not so clear for earnings penalties. There it's a little less systematic. The pattern you see here for employment, that actually follows quite closely what we see just in the raw gender gaps, just looking at employment gaps between men and women in the US. You can see that here. It's kind of the same picture that gender gaps are small in the central and north central part of the country and relatively big everywhere else. And similar for the earnings penalties as well. So, so that's sort of how it looks cross-sectionally. This has changed over time in the US, so you can do these kinds of heat maps over time, which is what I'm doing here. So, so similar types of maps where you have a heat map in earnings, penalties prior to year 2000, after year 2000, and similarly to employment. And you see, of course, child penalties used to be way higher in the US than they are today. So here, the billing of child penalties here is done in the same way, both before and after 2000. It's not like the fact that these are all light doesn't mean that child penalties have almost disappeared in the US. They're still quite sizable. If you look at these colors here, it's still child penalties that vary sort of between 13 and 40% in earnings, and also really large variation for employment, but it's just much smaller compared to what we had before 2000, where the child penalties are kind of between 50 and 90%. So there's all this. So there's a ton of variation within the US across states, and a ton of time variation as well. And so the key question is sort of what's driving this variation. Okay, any questions?
Yes, sir. I actually have a question regarding the methodology. So from my understanding, the validity of the method is based upon the assumption that man and woman, they self-select into having child based on the same characteristics. Right, is that correct?
Men and women select into having a child based on the same characteristics. I wouldn't say it like that. I would say it's a parallel trend assumption conditioned on the age and year controls.
Yeah.
So it's only up to a trend. It's only up to a trend.
Right.
So men and women would have yeah, so if not for having children, men and women would have evolved in the same way over time.
Yeah.
Aging controls. That's the assumption.
Because I saw earlier you showed a graph that men with child and without child are very different in the observable characteristics, but women are almost very similar.
Yeah.
So I just wonder whether this makes this method valid.
Yeah, but that's what shows, right? So the fact that women are very similar with and without children shows that the positive selection from having is there both for men and women, right? Because we know women are incurring large child penalties. We know that from the empirical studies using better data, many of which I showed you yesterday, right? So the fact that women, just on average, are quite similar, say, in terms of earnings, when they have kids and not have kids, despite the fact we know they incur a huge child penalty, means that there's a positive selection that offsets that. So there's positive selection for both. But in terms of validating my approach, that's hard to do for the women. I'm really doing that for the men because I know they're supposed to be flat.
Right.
And then the assumption is that also works for women. That is, but it's still only up to a trend. That's still only up to a trend. But yeah, that is the assumption. So there's an assumption that goes into this that I'm not validating directly. But then the advantage of it is that I can do it with data that I have available pretty much everywhere.
Just wondering how to think about the heat maps or like the global maps that you're delivering.
Yeah.
In the sense that the darker colors is not necessarily that good. because it ties different institutional differences, right? So there might be unemployment benefits or benefits for women.
Yeah.
And that might end up in having higher child penalties just because they don't go back to the.
Yeah, so I think, so there are a ton of things that are varying across these different places. I think the key advantage of trying to do this approach that we can really map out the variation across spaces precisely because I'm thinking about those mechanisms, right? I mean, when we only had a child penalty estimate for Denmark and Sweden and Austria, for example, I mean, we're very limited in what we can do in terms of exploring these mechanisms. Now we can begin to really think about sort of more granularly what is varying across these different places here. I'm still in the very early stages of trying to do that, so I'm not going to be able to present you too many results along those lines, but I'll talk a little bit about the social norm story that we discussed yesterday as well. But yeah, there are a lot of things here. They have different industrial compositions in terms of fraction, fraction in agriculture, the fraction self-employed, and so on. And these different types of industries and occupations come with very different types of degrees of job flexibility. So that could matter as well. So yeah, there are tons of things that are just varying here. So far, this is just describing, this is what it looks like in the US. There are certainly things maybe that, might be surprising if we go back to this one, right? The fact that maybe, on the West Coast and in the Northeast, at least employment penalty is actually really high, which might be probably surprising. Maybe you expected that places like New York and California and New England will probably have relatively low penalties because we think of them as gender progressive places. But of course, those are very different labor markets, very different gender equilibrium, and so on. And that could be part of it as well. So I think that's kind of where I would like to go with this. So let's just start mapping out the gender norm story and see how that correlates. But we can already kind of see from those maps that we're not expecting for this to just work cross-sectionally, because there are clearly some relatively gender progressive states, at least based on our general knowledge, that have relatively high penalties. So I'm going to use some of these questions that we've been talking about. Specifically the US, I'm going to use the General Social Survey which is available from 1972 to 2016. To really sort of exploit the time variation here, I'm going to focus on 3 questions in that data that's available in all of the different decades. We talked about some of these types of questions yesterday. So the first question is, it's much better. Do you agree, strongly agree, disagree, strongly disagree with these different statements here? It's much better for everyone involved. It demands the achiever outside the home and the woman takes care of the home and family. A working mother can establish just as warm and secure a relationship with her children as a mother who does not work. And a preschool child is likely to suffer if his or her mother works. So I'm going to use these 3 questions. They're available throughout and create a gender progressivity index by essentially taking the average of these 3 questions. Now, to make them comparable, these are different kinds of questions. So specifically what I do is I standardize each question separately to have mean 0 and standard deviation 1, and then I aggregate them into one gender progressivity index. If you do that, what does social norms look like in the US? So it looks like this. So here, darker colors means more conservative, and lighter colors means more progressive. And you can see here, so yeah, basically the South is gender conservative. North Central is indeed gender progressive. It's also the Scandinavian part of the US, maybe that's part of it, I don't know. Utah is very conservative, exactly what we expected. And here California is relatively somewhere in the middle, relatively progressive. Similarly, New England, relatively progressive up here. So that's kind of, yeah.
So are these things, do they tend to be strongly positively correlated with public policies that also sort of affects child penalties in a certain way, like also the availability of abortion, kindergartens, support and so on? So I'm just thinking how to separately identify public policies from gender norms.
Well, at this point where if you're comparing this map to the previous map, we're making a cross-sectional comparison between, say, the South, Texas, Florida, Georgia, and so on, to say California, New York. It's really not separately identified at all because there are just a ton of things that are co-varying. Now, we discussed this a little bit yesterday, the whole idea of, so one thing that clearly varies across public policies are different, welfare policies, tax policies, very few places in the US have much in terms of parental leave schemes, and childcare isn't universally available at young ages, so there's just much less of that in the US. But all these policies, clearly, there are differences in these policies across these states, and that could be part of what's going on as well. But as we're going to talk a lot about tomorrow, is that in general, the impact of public policies on child penalties just seems to be quite small. So I don't think, that's not my, I think that is a concern here. It's actually not my main concern. I have a bigger concerns that have to do with the equilibrium of the labor markets. And say the labor market in New York City is just very, very different from the labor market in South Dakota. Very different types of jobs, very different degrees of job and flexibility and so on. Which means that we definitely want to go beyond this cross-sectional variation here, which I'm going to do in a very simple way in a second. But there's still a lot more to do. Okay, so now we have the cross-sectional variation here. That means, you know, what we can one thing we can certainly do is to just kind of compare these two maps. That was basically what we were just talking about. So you just plot child penalties in different states in the US against the gender progressivity index, and you know, the correlation we're looking for that would be consistent with a big impact of social norms, of course, that would be a negative correlation here. And clearly that's not particularly striking. It's essentially flat when we look at child penalties in earnings. There is actually, you know, a negative relationship when we look at employment penalties, but it's not incredibly striking. And I think that simply reflects that there are so many other things going on across states that we can't, you know, it would be too much to hope for to just go straight for this cross-sectional correlation. What we can bring in as well is the time variation. Because as I showed you earlier, child penalties have fallen a lot over time. And we can also measure the change in gender norms over time because we use these questions that have been available since the early 70s. So this graph here looks at that. So in both of these graphs, the red one is the change over time in the gender progressivity index. And then we plot that against the change over time in the child penalty and earnings, and over here in employment rates, focusing either on annual employment or weekly employment. And you see the time variation definitely is very correlated between these two. There's big, you know, in fact, for earnings, it's really quite, you know, perfect that you have very big increases in gender progressivity in the 70s and 80s. And that's also the time in which child penalties really fell in the US. And then there's sort of a period of more stability in the 90s and 2000s, and gender progressivity is also not increasing much during that period. And then you have some recent falls in child penalties, which are associated with an increase in gender progressivity. So just a pure time series correlation look quite good. Not that I would draw any conclusive causal inferences from this either, but there's certainly some strong correlations here. Now, so what would we really like to do that's sort of one step better than this? Well, it's really to combine the cross-sectional variation across the US with the time variation across the US and ask questions like, is it the case that in the parts of the US where norms are increasing faster, that child penalties are also reducing faster? So, you know, a difference in differences type thing. So that's the direction I move in here. So we start up here. This is just the raw data. But now instead of just, so I'm using all the observations across different states in the US and different times in the US. And just plotting the child penalty observed for a given state and a given time period against the gender progressivity of that state and that time period. Okay, so here it's kind of just still there's no difference in differences here, but you have a very in this bin scatter plot here, you have a very strong negative correlation. The slope here of 0.5 means that because these are standardized gender progressivity index, it means that when gender progressivity increases by 1 standard deviation, the child penalty goes down by 50%. 50 percentage points. I'm not necessarily causal, but that's the association in the data. Then you can include state fixed effects. That would control for something like the fact that, well, North Dakota just has a different labor market than New York in a time invariant sense. And you see that the negative correlation survives that. In fact, it becomes even stronger. And then in the two bottom graph, I take the next step and go, this is still not a difference in differences, right? For that, I need both state and time fixed effects. So that's what I'm trying to do down here. And I do that in the fixed effect specification with state and time fixed effects. And you see that doesn't really, that's pretty much flat. I do think it's not too surprising to me that I can't do this. This is a very demanding exercise to do with the data, given the types of outcomes. My outcome variable is child penalties, which is estimated. And my right-hand side variable is gender attitudes, which come with some measurement error. And I'm really looking at the correlation and the variation between them from period to period across different states. So this is a pretty demanding specification. So over here, I try to do something where I use a very use a simpler moment of the data. I simply just look at the long differences. That is the change from the beginning of this period to the end of this period in a given state in child penalties versus gender norms. So just a much simpler difference in differences there. And that again has a very negative association. So that's consistent with an impact of social norms. In terms of the policy question, now the threat is at least sort of we moved one step further. So now here we were concerned that well, other things have changed in different states over time that's correlated with these changes in social norms. So it would be a little aggressive to conclude that this is surely causal, but at least I think it's quite interesting that there is this, this type of variation. This is for earnings penalties, and you basically see the exact same for the employment penalties as well. So that's consistent with an impact of social norms and culture, but maybe we still have, I still have more work to do in terms of really trying to tease that apart from other things that have been changing over time with these different states. Okay, so that's this kind of simple approach implemented on the US. How are we doing with time? 5 minutes, okay. That's fine, because I already talked. So what I'm really excited about with this approach is provided you believe that this is reasonably convincing to do this with cross-sectional data, then we can implement this in so many different places and really move towards creating this world atlas of child penalties. So together with Camille Landais, we're in the process of building this global database. It's still work in progress. We're sort of building it out as we speak. Currently, I have estimates for 121 countries. And whenever I have panel data, I use the panel data. So we have the countries that we looked at yesterday where we have, admin panel data. And we, of course, use that for the countries where we have it: Austria, Denmark, Sweden, and Switzerland. We have some other countries where we have really good survey panel data: Australia, Germany, and the UK. But then we have a bunch of other countries where we don't have access to such data, and I'm going to use cross-sectional data to implement this kind of approach. A particularly useful resource is ICONS, which is this international collection of census data from, 90-something countries participate in IPEMS. We use 63 countries, namely the countries that have the kind of information we need to estimate this, labor market outcomes and information about children. But the beautiful thing about IPEMS is that they're really large data sets, typically 10% subsamples of the entire population. Sometimes you have several waves, which means that even for small countries, like say Fiji, you have hundreds of thousands of observations for Fiji. You can estimate child penalties for a tiny country like that. For large countries like Brazil or Argentina, you have about 20 million observations, which means that you have a lot of power and you can really begin to look granularly at variation within those countries. So I showed you some of these graphs yesterday. This one repeats a slide you saw yesterday, so I will not talk too much about this one. So that's the one that, we have these sort of enormously large child penalty in a country like Bangladesh, a child penalty of 60% unemployment. And at the other spectrum, we have this China, which is just the outlier in the whole world in terms of having very tiny child penalties. And we have a bunch of other countries in between. We can do this for so many different countries. Here are some more countries. Here's Fiji over here that I just mentioned. Fiji may not be the country that is, at the forefront of your thinking about this, but I put it there just because I think it's really neat that we can do it even for a country that has a population of, if I remember correctly, 800,000 people. We can also do it for a country like Iran because they're part of IPEMS, so we actually have pretty good data. We can do it for different cities, and again here I'm repeating things from yesterday, so I won't speak too much about it. We can go to the continent level, and also we can do what we were trying to do, which is to really begin to build out this world map. So this is the world map of child penalties as it looks currently. It's sort of, the gray areas of this map are the places where we don't yet have child penalties. The goal here is to keep building this out and fill it out completely and get a complete map of child penalties. So you can see globally, where do we have large child penalties? Well, it's basically the largest child penalties are observed in Latin America, in Central and Southern Europe, the countries we have in the Middle East and Australia, and Southern Africa and Northern Africa. Those are the places where we have the largest child penalties, and the places where we have the smallest ones is Central Africa and China, for example, and other parts of Asia as well. As I said, we can even sort of begin to look at regional variation within countries, so we can look at an even more detailed map, right, where we have variation within the US, within Mexico, within Brazil, Argentina, Russia, China, and so on. So we really begin to become very, very granular. And what we're just starting to do is, like, with this kind of variation, I think we can really begin to think about what are the mechanisms, because now we have so much variation and we can begin to look at how industrial composition, social norms, all sorts of other policies, et cetera, vary across all these different kinds of spaces, and to understand where child penalties are really coming from. Okay, so I am almost out of time, so I will. There it is. So, yeah, so there's this tremendous variation in magnitude. So child penalties are observed almost everywhere, as we saw yesterday as well. There's huge variation in magnitudes, however, and we really want to begin to explore the reasons for it. As you know, I'm very interested in the idea of culture, which I think is very important, but it's still sort of work in progress to really try and nail that effect. So sort of the future research agenda here is to really sort of expand and improve this world map and really build it out completely. And once we have that, we can really look at the different kinds of political institutions and cultural institutions, et cetera, in different countries, and see what kind of explains these penalties. Thank you.
time for a few questions. So building on Sarah's question yesterday on the baseline differences across the world, what is the female labor market participation in Sudan compared to Denmark? Like, how does that really, how should we think about this compared to this?
Yeah, I think that's a key question. We discussed it a little bit yesterday. Is to think about these baseline effects, because I guess what we can sort of learn prima facie from this graph is that in Central Africa, the child penalty per se explains much less of gender inequality overall than it does in some of these high-income countries, because there is quite a bit of inequality in labor market outcomes. There's a lot of inequality in labor market outcomes between men and women in Africa, and yet child penalties are lower. So they're explaining less of that gender inequality. Looking into these baseline effects, that's definitely at the top of the agenda here. One of the things that we really need to try and understand is the degree to which in traditional societies, a lot of the impact of having children is actually sort of an ex ante impact. It's an anticipated impact. That is, that it's a high income country phenomenon that women try and have a career in the first place, and then they pay the price after having kids. Whereas in other more traditional societies, they never really even try in the first place. And that could be part of what we're seeing in Central Africa, these kind of anticipation effects already built in. But yeah, the whole baseline effect is key. I don't think it's all of the effect in the sense that we're looking at employment penalties here, and employment rates aren't always that low in some of these countries. And I think part of it is that they have very flexible types of jobs. They work essentially in agriculture or small businesses, self-employed, just types of jobs that offer a ton of flexibility. And therefore they do work. May look different if we look at earnings, but that's something we can't do with this data. We're only able to look at.
Just because you're talking about the type of jobs,
yeah.
Since you have no, so you have the data for the US, you didn't look at sectoral differences, for instance.
Yeah, and I've looked a little bit of that across states in the US. And states in the US, so I looked at self-employment and agriculture across the US, and that actually doesn't explain much in the US. The differences across US states in those, on those variables actually isn't huge at this point. Maybe it was at one point, but not anymore. But yeah, more generally, I'm going in the direction of really sort of trying to document differences in different things across US states to see what can explain it.
Yeah, because I was thinking of the difference between the employment penalty and the earnings penalty. You can imagine like some state, as you said, like where like employment is just type of employment is not compatible with motherhood. Maybe there's huge employment penalty, while they in other states would be even easier to stay. That's your idea. So
one of the things I did show you for the US was sort of the baseline effect we just talked about for the world. That I kind of had for the US, where you can see that the variation in the baseline level of employment for mothers across US states correlate with child penalties. And once you add back in the child penalties, the counterfactual employment is pretty constant. So it seems like most states have the same counterfactual employment, but different child penalties, and therefore different observed rates of employment.
Okay, I think we, some mark, but I think we have to stop in the interest of time for our workshop that is also going to start again in 5 minutes, maybe 10 minutes, so we can get a chance to get a coffee. Thank you so much.